let me briefly introduce him. I think Shivkumar is old friends to the community, and he has a unique experience expanding across the academia and the industry. He received his bachelor from IIT Madras and then went to Ohio State for a PhD. And after that, he joined academia and became a tenured professor in RPI. And afterwards, he actually moved to industry and joined IBM Research, and then moved to GE Power. And now he is a CTO and energy and mobility sector in Microsoft Research R&D in India. And so today, our old friend Shivkumar will be actually talking about a new topic. To me, it sounds very exciting topic. It's about software and AI-driven renewable. So without further ado, let's welcome Shivkumar. Thank you.
Thank you very much, Minghua. Thanks to Norman, thanks to Prashant and other organizers for inviting me. So I'll be making the case that when you think of renewables, you think of solar, wind, maybe electric vehicles, batteries, and things like that. A lot of hardware and hardware getting cheaper and cheaper. But the pitch in this talk is that the future is going to be a lot more software driven and a lot more AI driven. Right? So I'll take you through that. Are you able to see my full screen, or is the top actually?
We can see.
Okay.
Yes, we
can
you
can see the full screen. Okay,
yes.
Fine. Okay, so I don't need to tell this particular audience about climate change and the commitments for the 2-degree centigrade for reducing greenhouse gas emissions. It means a significant bending of the GHG curve. And if you want to bend that GHG curve, these almost 3/4 of that greenhouse gas emissions is contributed by various forms of energy. And whether that energy is in energy use in buildings, transportation, industry, etc. Right, and that the fossil fuels used in that context are driving a lot of the greenhouse gas emissions. So a major pathway for energy decarbonization involves a 2-step process. One is take these uses of energy and electrify them so that they're more efficient, and they start using electrons instead of combustion, and then convert the source of those electrons to renewables, right? So this is a simple 2-step formula which can address a large fraction of these use cases. But of course, there are many other vectors, but this is the major pathway that the industry is generally pushing beyond, right? So this means that there's going to be a lot of demand for electrons as you have more and more sources of energy coming from electrons, and also a lot of demand for renewables, which is going to give you those clean electrons, right? And whether you and for technologies that can either space shift or time shift these clean electrons, such as energy storage or other forms of flexibility. So we have a lot of these curves that go up to the right and go up over a long period of time and for decades on end, right? So these are going to be very large markets. And these markets have been also driven in the past through significant drops in the capital cost of these options, such as solar, wind, battery costs have been seeing really eye-popping drops in cost, and that has allowed more and more of these technologies to be deployed without subsidies, and maybe with a bit of policy support and a push to the industry. But in several geographies, they are able to compete on their own, right, in terms of levelized cost of energy. But what we are seeing is that in the future, cheaper and cheaper hardware, cheaper supply chains, and essentially learning curves is not enough, or cheaper finance is not enough. The next wave, if you want to drive a greater penetration of renewables, is to deal with the various challenges or externalities introduced by these forms of renewables, and And everybody knows that the solar energy can be produced only when the sun shines, and wind energy when the wind blows, and so on, right? And that is also associated with a lot of volatility, whether it's clouds or spatially correlated volatility, or the duck curve as is seen in California. There are several various manifestations of this. So this volatility occurs at multiple time scales and has different forms for solar, wind, etc. So, if you want to have solar, wind, especially the variable forms of renewables, which are the cheapest, to have greater fraction of the demand served, by definition, it means that the rest of the source of energy will have a lesser share of demand served. And if these two, for example, are highly volatile, in one instance, they will occupy 100% of the demand served, in another instance, they will have 0%. It's going to be a big challenge if the other sources are retired and you will not be able to balance out such high volatility. So one of the big challenges is how do you get smarter in matching supply and demand of such green electrons? And there are various ways to do it, but broadly speaking, what happens is you have to measure demand, you have to measure supply through IoT, you have to match them through various mechanisms, typically market mechanisms, and those matching are increasingly happening at finer and finer granularity, right? Initially, it was done matching on an hourly basis. Now in different geographies, it's happening in 15-minute basis, and they're switching over these imbalance penalties and so on at finer and finer granularity. And in some leading markets like Australia, it's also happening at 5-minute intervals, right? And we expect that other high frequency trading and renewables and storage and so on, those policies have to be applied in minute or sub-minute in a seconds level basis as well. So these fundamentally, this idea of 24/7 dynamic real-time matching of demand and supply via market incentives, via mechanisms of the grid and policies, these are really amenable to software, right? And these are really going to be driven by software and AI. So the future is going to be driven by grids and resources that are going to be smarter, and they have to be matched in real time, right? So this is a fundamental problem that faces us. Now, what this means in terms of the industry is that if you look at the renewables industry specifically, in the past, it has been a small fraction of the energy mix, about 10 or 15% or much less. It involved a very high capital expense. To set up a wind farm or solar farm cost more than $1 billion, typically $1 to $2 billion for a gigawatt of wind or solar. And to finance this, to be able to raise this kind of capital as a sunk fixed cost required the establishment of long-term contracts, solid counterparties, typically government-owned or AAA rated counterparties who are willing to buy, and essentially very, very long-term contracts, 10 to 25 years, and very limited exposure to the short-term markets. And there were also in several geographies forms of subsidies. And so all the focus of the industry was on, hey, how do I go and build out such farms? Where do I find good resources? How do I set up finance? How do I actually get a signature on a very long-term contract and do the basics in terms of operations and so on, right? If you notice in everything I told you, there was no mention of software, right? It was nice to have to set up a bit of IoT, our SCADA systems, measure what's going on. And ultimately you do that for billing and so on and so forth, right? So software is not a big part of the mix in the past. But going forward in the future, software, as you have renewable energy becoming more than 15, 20% of the mix, a lower and lower capital expense as solar, wind, etc., becomes lower in cost, means that more entrants come into the marketplace. These long-term contracts, rather than being 25 years, are becoming 10 years or sometimes 5 years. And they also are becoming more complex, right? They have embedded in them 24/7 constraints. So for example, when Microsoft is issuing these long-term contracts, we have shortened it to about 10 years or so sometimes. And also almost most of the contracts are involve 24/7 constraints, which means that we will only pay the supplier for our data center demand in those hours, right? So if you supply me more than my demand, we will not pay you. So that's an example of a 24/7 contract. And this is not unique to just Microsoft. So, other cloud providers and Google or Amazon, others, and even bigger enterprise players have started going here. And the US government has recently also signed on to making 24/7 contracts. So all long-term contracts are getting complex, embedding in demand-supply matching. And there's an increasing exposure to short-term markets. So if you look at what's going on in Europe, the energy markets price have shot up, and it is possible for you to set up a solar or wind plant, and as long as you can get connectivity quickly into the grid, you can actually make back your capital expense within a couple of years at the rate at which the market is pricing and the short-term market. So there are a lot of incentives, higher short-term market prices, and also as the cost of renewables and the levelized costs have dropped, long-term contract prices are also lower than average short-term prices, because short-term prices are driven by the marginal cost of the fuel, especially fossil fuels. So there's an increasing focus on autonomous operations, increasing focus on how to not just produce gigawatt hours and megawatt hours, but how do we deploy, or how do we convert those gigawatt hours to dollars, right? So we call it a monetization problem. How do I make money? So making money was not a big challenge earlier. I know as long as you can produce those gigawatt hours and you have a long-term contract, you just collect the money and move on, right? So there is the CapEx, the operations and the monetization cycle is shifting more towards the right side, towards monetization and orchestration of assets, and orchestration of multiple assets. So you could have a solar in one place, wind in another place, and battery resources. And you may have a portfolio of these along with other potentially fossil fuel plants as well. How do you orchestrate and manage your portfolio against short-term markets and maybe some long-term contracts and so on, right? So this is the brave new world we are entering. And this will become even more pronounced as we go along, right? So as as solar and wind penetrate more, you will have to include this. And sometimes it's also called firm renewables or 24/7 renewables in different contexts, right? So for example, you cannot establish a solar plant in California today unless you pair it with storage. Almost all plants, whether solar and to most extent wind, also come in paired with energy storage. Okay, so all of this have to be also paired with software, data, and AI, right? So in summary, deep renewables integration is actually a software problem as much as it's a hardware problem, right? In fact, it's lesser and lesser of a hardware problem and more of a software problem, right? So this you need digitization to manage the grid. You need for deep renewables integration, you need to be able to measure demand and supply and your resource levels and aging and other factors in real time, model it in real time, and take autonomous decisions under uncertainty, right? And you're going to have more and more uncertainty going forward. Handling these uncertainties and taking decisions under uncertainty are going to be important. So, and also there's growth of flexible resources. Your electric vehicle can probably charge at different times in the day. Many demand sources also come in with IoT and local actuation controls, so they can potentially be flexible demand sources and so on, right? And in fact, cloud computing is the ultimate flexible energy resource, which we call a virtual battery. So Microsoft is focusing on these 3-4 building blocks to help the industry. One is providing the infrastructure for real-time measurement and modeling of demand and supply, and creating auditable records that can be used as a foundation for tags, for contracts, and other audit requirements. So that's the blue box on the bottom left. We are also working on advanced forecasting technologies, which can essentially convert uncertainty to risk, whether it's price forecasting, demand forecasting, supply forecasting. And these problems are becoming harder because they are dealing with more and more non-stationary processes and processes that involve multiple agents over time as well. And once you have the forecasting, you need to be able to take decisions, and these decisions could involve orchestration of resources. It could involve participation in energy markets, energy trading, etc. So, and then finally, you can put all this together to actually apply to the cloud itself as a resource. You could apply to any resource. It could be a solar plant, a wind plant, so a combination of a portfolio of these, and ultimately to cloud itself as a flexible energy resource. So these are the various areas we're working on. So what I'll do is, in the remaining time, I'll give you a bit of an overview of some of these, time permitting. So in 24/7, we've been working with various customers, and Microsoft has also, in its procurement of renewable energy for our cloud computing, has standardized that all our procurement in many parts of the world, especially Europe and US, is going to be 24/7 matched. What that means is that we require hourly matching of our demand in our data centers, etc., to the supply that is produced. And the supply can come from any form of clean energy. And so, for example, if you just set up a solar plant and offer this, you will not be able to meet the requirements of 24/7 because you will not be able to supply during the night when we have demand. So typically what this means is that providers will have to take a hybrid combination of resources, in some cases also some forms of storage resources, to meet these contracts. So, and we've built essentially the infrastructure, the IT infrastructure for being able to coordinate this with our suppliers. And so this was the origination of where we started off all of this. But we have expanded this to involve essentially matching demand and supply with any other forms of relevant data, right? So, for example, emissions data in real time, or sort of other forms. Like, for example, you could aggregate the supply from multiple distributed sources. So, for example, in Ireland, we've signed up a PPA, a power purchase agreement, where the supply doesn't come from a single farm, but it comes from essentially hundreds of rooftops, which can be aggregated to provide the supply. But also that supply is organized to be 24/7, right? So these are interesting things that we do. And of course, there is storage in some of these cases. We've worked with some clients like Vattenfall and so on in Europe to pioneer these. This was several years ago, but now it's some of these are standard. But the same infrastructure can be now offered to essentially a wide variety of applications. For example, if you set up an electric vehicle charging station and you want to guarantee that all your electrons are generated in real time through our green electrons, so this accounting infrastructure can ensure that. So carbon accounting, distributed PPAs, new forms of EV charging with guaranteed supply. And some of these also are basis for subsidies as well. So once you have this sort of matching of demand and supply and the ability to match, you can do forecasting. So forecasting is, of course, a well-known problem, and there are lots of open source forecasting tools. The DARTS library is fantastic, available on Pandas and so on, right? So the challenge that we are trying to solve is how do we deal with essentially non-stationary forecasting challenges, such as micro weather forecasting, price forecasting in these markets, and so on. So what we do is we have a framework that can essentially allow you to integrate data from multiple open sources or APIs that are available. There are companies like Soulcast, Dark Skies is a company that's recently been acquired by Apple. There are other third-party weather forecasters and others. So you can take external forecasts for any particular site, and that gives you a baseline forecast at that site. And then you can also take local data like generation data and so on, and IoT data, and then put that together in an interesting approach to essentially come up with forecasts that can be used to forecast either the weather or power or sort of price and other sort of variables, right? So we have a flexible and extensible forecasting technology that we are currently working with different partners and deploying it in the market today. So this is an example of raising the bar for forecasting and also making forecasting more as a platform service that can be used, just like we had sort of infrastructure as a service and platform as a service. This is a higher order platform as a service capability for this industry. So this was a paper that was published in KDD last year, 2021. I won't go into the details of it, but it involves essentially wavelet decomposition of a complex time series, in fact, multiple time series, and then building separate models for each scale, the long scale, medium scale, short scale, with appropriate nature of the models for these scales, and having an encoder-decoder structure to put it all together. Just to give you a sense of the value of doing such things, so we have compared it with some open source state-of-the-art time series technologies, and I'll just skip some of these things. But just to give you an idea of the performance, if you don't do this and just do standard time series forecasting, your errors are quite bad. You have bias, variance, and you don't track the underlying highly volatile process very closely. But then once you have, once you combine it with some of these exogenous forecasts, as well as you're able to fuse it with the better algorithms, your performance dramatically improves. And then the error of these forecasts is going to drive some of your economic costs, right? And as I mentioned, this is going to drive things much more going forward. So what we are doing is essentially having a framework that is extensible. We continue to improve it, and we're working with several customers around the world. And ultimately, hopefully, this will be made open so that it'll be available on our cloud for more broader consumption. So the next layer we're working on is really to take those forecasts and actually drive autonomous decisions under uncertainty, right? So again, there are a wide variety of problems both on the wholesale side, retail side, in the energy space. You could have EV charging problems. You could have like energy trading problem, portfolio optimization problems. In fact, there are a wide variety of buzzwords like virtual power plants, DER, etc., that are available in our domain. But many of these problems can be modeled as essentially decision problems or optimization problems under uncertainty in different levels of data availability. So our goal is to help, have abstractions, bring all the data together, and have choices of various decision engines, and ultimately make these choices also relatively automated using AutoML type techniques to choose the right decision engine for the given amount of data for the problem of interest, and make it easy to express these problems through sort of an abstraction interface. So what we've done again is as part of different interns and others who work with us and various client engagements, we have modeled various problems, and we are now bringing a variety of these problems into this common framework, right? I won't go into the details of these specific problems. You can see some of these pictures from earlier: distributed PPAs, carbon emissions optimization or monetization of batteries, or even participation in markets, etc., and multiple markets. So roughly, you see the same sort of block diagram structure that we saw in the forecasting to be able to abstract out energy sources. Ultimately, these will be digital twins of each of these energy sources, modeling out different types of markets: long-term markets, short-term markets, ancillary services markets, etc. And then having a variety of decision engines and the data infrastructure to be able to feed forecasts or feed data into these decision engines. And maybe in some cases you don't have enough data, so you might choose one kind of optimization, and then over time, as you have more data, you would choose a reinforcement learning approach. So finally, I'll end with this concept of a virtual battery, which I guess some of the groups here are also working on. So we look at applying all the things that I've talked about ultimately to any resource, whether it's a generation resource or a demand resource. And cloud is an ultimate flexible energy flexibility resource, because ultimately, rather than having clouds which are further away from energy resources, you could actually have a future where you could take the data center and co-locate it with renewable energy resources, right? So this obviously gives you a direct benefit of avoiding the transmission and distribution costs, but you also have to deal with the volatility of the generation of these resources. But if you expect a future where these costs are lower, there'll be oversupply of these resources. So the costs at the site will start dropping on average to be very, very low on a levelized basis. But in addition, you can also provide an additional battery-like service, right? So essentially, the data center also operates pretty much like a battery, essentially absorbing energy, excess energy, and then then releasing excess energy by not turning on computation when that has more value in the network. Right. So we also focus on shifting computation to meet the availability of energy. So one is to have flexible computation at a single location, but also the ability to sort of migrate applications across locations. So again, so we have done just the first sort of incarnation of what you could do here. So again, the goal here is to have be able to use a base level of energy for computation to support a base level of energy demand. And then beyond that, you can allow the energy to be fed into the grid. And ultimately, you can flex up and down depending upon how much volatility you're willing to absorb and how much is the price or the value of that volatility. Okay, so given the time, I will just give you a high-level overview of the various aspects that are involved. So what we believe is that going forward, as renewable resources are available in different parts of the world, and there is high-speed compute as well as high-speed communication available through satellite technologies like LEO orbit, low Earth orbit satellites. We believe that you can have essentially simple managed small or mini data centers that can be put at renewable energy resources. And you could also have increasingly recycled or depreciated servers from our primary cloud centers that can be moved to these locations, right? And that dramatically lowers the capex, and we are increasingly seeing a lot of our the volume of depreciated servers is skyrocketing as well. So then you support that with a variety of flexible scheduling at the compute level, at the value stacking level, where you're trying to stack not just the energy value, but also the compute value appropriately. And then ultimately you can move or schedule computation across these and provide abstractions on top. Okay, so finally, just to summarize, see what we are seeing ultimately is that renewable is already the lowest cost and is becoming cheaper and cheaper on an aggregated or a levelized cost, average cost. But increasingly, the externalities of renewables have come to the fore, and that's going to dominate the discussions going forward, which means that things like complex contracts, short-term market participations will become important, and as energy storage costs increases, you're going to have a hybrid set of resources that needs to be orchestrated. So similarly, on the finance side, there's a lot of push from the ESG and financial community, which also will drive more and more equity financed renewables, and with higher and higher short-term market prices. That's also going to create an incentive for more software short-term market exposure, which means risk management and managing how much you make on these markets becomes important. So we believe that software, AI, and solutions in this space are going to become dominant, and we are preparing for that future and to help the industry go forward. With that, thank you.
Okay, thank you. Thank you, Shivkumar, for the very informative talk, very interesting as well. If you have any question, yeah, I see several hands. Don't know which one raised first, so maybe I go with the one I saw. Herman, do you want to go first?
Thanks, Minghua. Just a question to you. What do you think would be more suitable with regards to renewable energies? I mean, the co-location of data centers and renewable energy sources, is it wind, is it sun, or is it a combination of both? And what kind of key performance indicators could you, let's say, identify, and where would be the efficiency of such systems? I mean, would you reach 100% renewable supply, 80%, 50%, 10%? What's your thinking here?
Yeah, this is a new concept, and for even some folks with Bitcoin mining are trialing this out. So yeah, you can have just a single form of renewables like solar or wind, but increasingly there are hybrid solar and wind combinations in a single site that are possible. So we are being neutral to the nature of these plants. I think the upshot, of course, is that if you don't have local supply, for example, if solar doesn't produce in the night and you have a data center sitting there, which has an opportunity cost, and then it'll have to draw energy from the grid to compensate, right? So there are trade-offs of that sort. So I would expect that typically some mix of renewables or hybrid renewable plants would be the ideal to give a little bit of balance or to have some storage. Yeah.
Okay, thanks.
Okay, the next one will be Sonia, and afterwards will be Keshav. Thank you.
I was just wondering, the workshop is on society, climate, and sustainability. So where do you see in this future the role of people and society and behavior change and things like that?
Yeah, I think the flexibility has to come from all sides if you're going to be able to economically match demand and supply. Now, the flexibility can come from the demand side through incentives or economic incentives, and then either people making changes, and that would be that will involve society and engage the society. The other is, of course, that will be combined with a lot of automation to make these high frequency choices of and so on, right? So people will be typically involved in policy choices and expressing their preferences, and then the actual fine grained details will be managed through software AI and so on, right? So I think that's the primary vehicle, mostly on the demand side, and of course where there are distributed renewables options. The increasing penetration of that is the other angle, right? Yeah, so I think these are obvious ones.
I'm really wondering about the relationship between the automated part and the people's part. I think this is one of the big challenges.
Indeed.
Okay. Thank you, Sonia and Kisha.
Thanks, Shiv, for that overview. I had a question, not about Microsoft, but the rest of the industry, the cloud computing industry, I guess, because Microsoft has really taken the lead, especially with the carbon negative pledge. But is Microsoft an outlier, or are these kinds of 24/7 PPA type arrangements and other kinds of things that you're talking about becoming more standard?
They are becoming more popular, Keshav. I think if you look at the power law, it can help you in some ways. If you look at the amount of PPAs coming from utilities versus coming from business to business contracts, and the B2B share of the overall market has already grown to 40% of total PPAs in the world. Okay, and out of those B2B, most of the the cloud players and the others, related players, large enterprises, have a disproportionately large share, right? So, and most of them are going towards 24/7, and even the US government and some other governments have started going towards that. So, directionally, there's a push towards that, and also it is going to become necessary because as you have greater penetration of renewables, the value of the renewables if you oversupply it, it'll have low value, right? So that demand supply mismatch will automatically drive a shift towards 24/7, right? So, but some of the bigger players are driving that, and they happen to be a larger part of the market.
Thank you.
Okay. Thanks for the Q&A.